Good morning, everybody. Can you listen to me? Please raise your hand. See, tomorrow, in this, how many? See, you raise your hand if you say yes. Like today evening, also there is class for so many other students. Is it true? Raise your hand. Evening also, but tomorrow Sunday there is no evening class. Tomorrow I am going to take from 7 to 1. Okay, we will confirm the schedule by today evening. But tomorrow networks will be there from morning 7 to afternoon 1. Is it okay? Raise your hand. Okay, see, for you also parallel subjects are going on, sir. For me also recording studio, offline class like that. That is the reason we are doing our best in handling multiple batches. But for you also, we are not wasting time. Evening schedule, some other subjects will go on. Don't worry about it. But in a relaxed way, my subject here itself along with me learn. Okay, and notes we are giving already. Plus this recorded videos also you can listen multiple times. So that way you please improve yourself. Okay. Chalo, now see, quick review what we did yesterday and we will go forward today. Now, yesterday it was day 7 where we were doing BC basics, more BC basics. Like yesterday, yes, chapter 1 was perfectly completed. Okay, now here there is a problem where I asked current, but here all elements are parallel. So I did current division rule. But target element 3 ohms I did not touch. But remaining non-target passive elements I lumped because all are parallel. Then current division in 2 branches that I did, but practical direction is opposite to reference, so answer is minus. Right side dependent sources I started. Okay, there is a current dependent voltage source, but still KVL I got everything, and power delivered was negative as it is a sink. Then also here V0. First from Ohm's law I wrote V0 by 2. See, if this is V0, this is 2. This current should be V0 by 2. And current should enter positive in a passive element. Then I wrote a KVL. Now these are independent mesh concepts. Again, I got V0 by simple current division and Ohm's law. Then here, though there are so many sources, but simple KCL, KVL and Ohm's law helped us. That is what I want to prove. Be simple in life. And here also power delivered by the dependent current source is positive as it is acting like a source. This is an interesting problem where I need V0 and I0. V0 is 60 volts and I0 is 5 amperes. Now here there is a gate problem here. He is asking R, but see with the given data, I applied KCL and KVL. See, I am talking about fundamentals, sir. KCL, KVL, Ohm's law like that. Now here also, there is an open circuit and short circuit, but still I need V0 and I0. Here, similar model with dependent source. Yes, currents require closed path, but voltage does not require any such things. Voltage can exist even under open circuited path. That is what is the dependent source doing here, interestingly. And I got V0 as minus 8 volts. Now here, insufficient data problem, so V0 cannot be determined. Now this model in the right side, everyone thought it is parallel, but actually it is not parallel because this connection inside the box we don't know. So I applied KCL to get V0. Then I wrote a KVL. Okay, in that path where voltages are visible. Here I applied KCL and Ohm's law to get what is VC minus VD, which is 8 volts. Now this is a problem to find I, so I wrote a KCL at surface level and KCL at node level and KVL. Here it is a symmetrical network. Okay, that is why current division was very simple and KVL, and then I got the answer which is called I. Current source in series to any element is redundant. That is what is the proof here. Current will be always constant. Here also, if the voltage source act as a sink, current should enter positive. If current is entering positive out of 12, something is going inside. So this I should be less than 12. Less than 12, only one option. See how interesting questions he is asking in gate. So this is option based answer. Okay. Then here also IES objective. He is asking I, but he gave the hint. With the given hint of 1 ampere. Yes, with the given hint of 1 ampere, I wrote all KVL, KCL, and Ohm's law. I got the answer. Now it is a ladder network, simple KCL, KVL, and Ohm's law. Here also grid. Yeah. Here I introduced a parameter X, and then we got the power. Here also find the currents to all the elements. Here the bridge is neither balanced, nor symmetry, nor current division, nor voltage division. So KCL, KVL, and Ohm's law only helped. Then we started methods of analysis. These are two powerful techniques. One is mesh and nodal. Model 1. In model 1, one independent voltage source, one independent current source as external branches. Very easy it was. Okay. In mesh analysis, I2 is a comparison equation. I2 is minus 2. But in nodal analysis, V1 is 10. That is the meaning here. Then In model 2, I took current source as a common branch between two meshes. It is called super mesh. Open and write KVL. Open and write KVL. Okay. Then in model 3, I took voltage source as a voltage source as a common element between two principal nodes. Yes, I wrote. Yes, I took voltage source as a common branch between two principal nodes. Then that is called super node. Here, short circuit and write KCL. Okay, now in model you short circuit and write KCL. That was the interesting observation. So we understood what is super mesh, what is super node. Now anything will be combination of that only, sir. Okay. Then your conductance problem is today give. So calculations, you do it. So I'm continuing from there. This is day 8. Now we will start problems with dependent sources. Now here my question is determine Vx by using mesh and nodal analysis. Okay, determine voltage Vx by using mesh and nodal analysis. Okay, now determine voltage Vx by using mesh and nodal analysis. Ten volts, 1 ohm, 2 ohm, 3 ohm. This is Vx and this is 2Vx. Okay, determine Vx by using mesh and nodal analysis. Okay, the question is determine voltage Vx by using mesh and nodal analysis. Okay, now here extra thing I took is a dependent source. It is a voltage dependent current source. It is a voltage dependent current source. So take it as a current source. Okay, determine voltage Vx. Yes, determine voltage Vx by using mesh and nodal analysis. Okay, here voltage Vx is a dependent parameter which will affect the property of dependent source. Now here in normal mesh analysis, everybody, here in normal mesh analysis, okay, what I want to say is there are two normal mesh equations, but apart from that, there will be one link equation. What is link equation? Link equation is the link between the dependent parameter Vx and the mesh currents. See, when dependent sources come, don't confuse, sir, don't worry. What I want to say is, normally in mesh analysis, there are two meshes. Plus what is extra? There is one dependent source. Okay, two meshes plus one dependent source. Yes or no? So that extra link equation you have to write. So first I am doing mesh analysis. So first of all, I told us normal mesh currents. This is mesh current I1. This is mesh current I2. First, let us write normal mesh equations. But because there is one extra dependent source, there is one extra link equation. That link equation is a link between the dependent parameter and mesh current. You have to write them link. That link can be Ohm's law or current division or voltage division, KCL, KVL, anything is okay. Suppose there are 10 meshes with 4 dependent sources. Listen carefully. Suppose there are 10 meshes with 4 dependent sources. Okay, na? 10 meshes with 4 dependent sources. Okay, then total 14 equations you will get. That 4 extra dependent source equations are called what equations? Link equations. Okay, that 4 dependent source equations are called what equations? They are called link equations. Is it okay? Chalo, link equations, please. Okay, now everybody listen now. So normally first mesh. Okay, now normal mesh equations I am writing starting from here. Minus 10. Okay, plus 1 into I1. Don't worry about Vx, please. Vx is a dependent parameter which will affect the property of dependent source that we will write later. Now, what type of dependent source is this? It is a voltage dependent current source. It is a voltage dependent current source. So treat it like a current source. But we know when current source come as a common branch between two meshes, when current source come as a common branch between two meshes, it is called what? Super mesh. It is called what? Super mesh. So open and write the KVL. So minus 10 plus 1 into I1. Now current source came now. Right now I don't know the voltage across it. It will be there, but we don't know. So jump into the second mesh. That is called super mesh. 2 plus 3, 5I2 equal to 0. 5I2 equal to 0. This is the first equation. Second equation, this is I1, this is I2. This is I1, this is I2, but resultant is going up now. So I2 minus I1 is 2Vx. I2 minus I1 is 2Vx. Now these are the normal equations because resultant current is going up. That will happen only when I2 dominate I1. So I2 minus I1 is 2Vx. Now link equation. What is the link equation? Yes, what is the link equation? Vx is 1 into I1. The link equation is Vx is 1 into I1. That is the link equation. Vx is 1 into I1. That is the link equation. Okay. Everyone observe these three. See, first is a normal super mesh. Why is super mesh? Because there is a dependent current source as a common branch between two meshes. So open and write the KVL. Then difference I2, I1. But resultant is going up now. So I2 minus I1 is 2Vx. Okay na? Yes, I2 minus I1 is 2Vx. Okay. Then link equation. Vx is a voltage across 1. So Vx is 1 into I1. Vx is 1 into I1. Okay, everybody? Yes, with that, yes, I confirm that. Yes, these are the three equations. Now solve them. Chalo, my requirement is Vx now. Vx is nothing but I1 only. So first you substitute there Vx 3. That is nothing but 3I1 minus I2 is 0. I'll multiply this with 15 times. Or 5 times. 5 times minus 5I2 equal to 0. I will add this and this. If I add this and this, it is 16I1 equal to 10. 16I1 equal to 10. So from this, I1 is 5 by 8 amperes. I1 is 5 by 8 amperes. If I1 is 5 by 8 amperes, that implies Vx is 1 into I1. That is also 5 by 8 volts. 5 by 8 volts. Okay, Vx is 5 by 8 volts. Okay, now. Okay, this is 5 by 8 volts. Okay, that is about Vx. That is about Vx. Okay. Now I am doing the same problem by nodal analysis. Okay, same problem. Let us also check it by nodal, but here also what is extra with dependent source? Let us understand. Okay, what is extra with dependent source? Now I need nodal analysis. Now I need nodal analysis. So total, how many nodes are there? 1, 2, 3, 4. There are total 4 nodes. There are total 4 nodes. Okay. Yes. Out of that, simple nodes are waste. Okay. Now there are 2 principal nodes. In that one principal node, I will take a reference and let this be V or V1. Let this be V or V1. Now actually nodal analysis also there is one standard equation. In nodal also there is one standard equation. But because there is one dependent source, there is one link equation. So in nodal also there is one standard equation. Yes, no doubt. And because there is one dependent source, there will be one link equation. So in nodal also, sir, suppose there are 10 principal nodes. In the 10 principal nodes, one principal node you take it as reference. Okay, 9 equations. Plus there are 4 dependent sources. So 9 plus 4, 13 equations you get like that. So here there are 2 principal nodes. In that one is reference. So one principal node, one standard equation plus one link equation because there is one dependent source. If there are more dependent source, more link equations will come. But what is the link equation? Link equation is a link between the dependent parameter and the node voltage. Dependent parameter and the node voltage. That we will write. Okay, na? So the first nodal equation, normal equation, sir. So nodal normal equation I am writing. KCL here. This current plus this current plus this current should be 0. What is this current? V minus 10 by 1. V minus 10 by 1. This current is how much? Minus 2Vx. Minus 2Vx. What about this current? What about this current? Yes, V by 5. V by 5 equal to 0. V minus 10 by 1 minus 2Vx. V by 5 equal to 0. If I take LCM 5, 6V minus 10Vx equal to 50. 3V minus 5Vx equal to 25. That is the first equation. V minus 10 by 1 minus 2Vx plus V by 5. So 6V minus 10Vx equal to 50. So I do this. Now what is the link equation? So what is the link equation? See, this is already 10 volts with respect to ground. Yes or no with respect to my reference. Okay, with respect to my reference. Okay, this is already 10 volts. Yes or no, this is already 10 volts. Okay, now Vx is a voltage across 1 ohm with this reference. Vx is a voltage across 1 ohm with this reference. Vx is a voltage across 1 ohm with this reference. 10 is more positive than V by Vx. 10 is more positive than V by Vx. Okay, now 10 is more positive. Yeah, than V by Vx. So Vx is 10 minus V. So Vx is 10 minus V. Okay, Vx is 10 minus V. Okay, that is the equation. So now if you solve these two, okay, we need finally Vx only, we need Vx only. So 3 into V is again 10 minus Vx. 3 into, yeah, 10 minus Vx minus 5Vx equal to 25. So from that I can say 8Vx equal to 5. So again Vx is 5 by 8 volts. Same answer, you see. Same answer. Here also same, here also same. Okay, so dependent sources come, don't panic or don't worry, sir. Okay, dependent source come, don't panic. Chalo, sir, I'm giving now to extreme problems. With this, we can close nodal and mesh. But this is the level of what IES conventional is about, all about. But here I'm not solving anything. See my question, just write mesh and nodal equations for circuit below. For circuit below. Okay, just write mesh and nodal equations for the circuit below. Okay. Okay, chalo everybody, just write mesh and nodal equations for the circuit below. Okay, my question is just write mesh and nodal equations for the circuit below. Here, there are two independent sources, one independent voltage source, one independent current source, and there are two dependent sources. One is a current dependent voltage source, one is a voltage dependent current source. My question is just write mesh and nodal equations for the circuit below. Now, how to start these problems? Listen now. See, first of all, here, yes, here I am arguing. Yeah, here I am arguing how many nodes, okay, how many nodes, how many branches, and how many meshes are existing. Okay, I will give you the chance, sir, you're right. See, first of all, nodes 1, 2, this entire thing is 3, 4, and 5. Bends are not nodes, please. See, this entire thing is only one node, please. 1, 2, 3, 4, 5. So nodes are 5. Branches 1, 2, 3, 4, 5, 6, 7 branches. Obviously, meshes are 3. So in mesh analysis, 1, I1, 2, I2, 3 mesh, I3. So in mesh analysis, we get 3 currents, okay? So 3 equations. So if you do mesh analysis, we get first 3 standard equations. Plus how many link equations? Yes, because there are 2 dependent sources. One is a current dependent voltage source and one is a voltage dependent current source. There are 2 link equations, okay? Total 5 equations. But what are link equations? Link equations are the link between dependent parameter and mesh currents. Dependent parameter and mesh currents. So now if you do nodal, there are total 5 nodes. But simple node you neglect, simple node you neglect. One of the principal node I will take it as reference. And let this be V1 and let this be V2. Let this be V1 and let this be V2. So in nodal also 2 standard. In nodal also 2 standard. Plus how many link? Yes, 2 link. Okay, there is a current dependent voltage source and voltage dependent current source. There are 2 link. Total how many? 4. Total 4. But what are the link equations here? Link equations are the link between dependent parameter and node voltage, dependent parameter and node voltage. So I am giving you 3 minutes, sir. Write them. Those who write this level correct, na sir. Yes, those who write this level correct. Don't solve. Only the level we can write, it's enough. Don't solve, please. My challenge here is, if necessary, such things we will use in future. And those who can write any network mesh and nodal, na sir, first of all, you can solve the problem. So I'm teaching you solving techniques only. Chalo, everyone should try. Write the equations. I'm giving you 3 minutes altogether. Okay, I'm writing UC. Yes, everybody, I'm writing UC. Array Shreyas. Shreyas, raise your hand. Shreyas, raise your hand. Array by Shreyas Sasi, please raise your hand. Shreyas, raise your hand here. Shreyas, hello. Others, put down your hand, please. Everybody, put down your hand. Everybody, please put down your hand. Only Shreyas, raise your hand. There are two people still raising your hand. Sai Chand, put down your hand. And Tulasi, please put down your hand. Tulasi, Shreyas. Shreyas, both mean same, na. I wrote first Vx as 10 minus V. But later while solving, I substituted. What's the problem? See, Vx is 10 minus V. But while solving, I need Vx, na. So I substituted V as 10 minus Vx. So this is solving. Both mean same, na. These are the equations where Vx is 10 minus V. But while solving, you bring Vx this side and V this side. Then V is 10 minus Vx. Because I need to find Vx, na. Both are correct only. Don't confuse. Equations. Yes. Okay. So understood, Shreyas? Okay. Okay, now here right side I am writing the equations. Everybody right side I am writing equations. I want you to follow. Okay. So everybody I am writing equations. You just listen. Now first mesh analysis. Everybody listen. First equation starting from here. Okay. Minus 10 plus 2i1 plus 2i1 super mesh, because dependent current source super mesh, but there is no element, no voltage drop. Again current source super mesh, double super mesh. Again I will open and go. Then it will be 4i3. Now voltage source, dependent voltage source, plus 5ix. Okay, now here if you write, actually it is 3 into i3 minus i1. It is actually 3 into i3 minus i1. But again current source super mesh, go here. Again current source super mesh, go here. 3 into i1 minus i3. That's again 3 into i1 minus i3. Okay, equal to 0. But actually here 3 into i3 minus i1 super mesh, again 3 into i1 minus i3, it doesn't matter. So it doesn't matter. Waste of writing. So yes, so the only KVL first, so the double super mesh is minus 10. Yes, minus 10 plus 2i1 plus 4i3 plus 5ix is 0. That's it. That is equation 1. Now I'm going to second mesh. See, all combined three meshes together, you wrote double super mesh. Now there is no direct KVL, only difference equations are coming. Now see, Vx by 6 is the dependent current source between two meshes, but it is going upward. So I took I1 clock, I2 clock, I1 clock, I2 clock, but resultant going up means I2 should dominate I1. So I2 should dominate I1. So I2 minus I1 is Vx by 6. I2 minus I1 is Vx by 6. This is second equation. Then third, see, I2. Now see, this 8 amperes is again common branch between mesh 2 and mesh 3, but it is going down. See, when it is going down, I2 should dominate I3. When it is going down, I2 should dominate I3. So I2 minus I3 is 8. Okay, I2 minus I3 is 8. That is 3. Okay, now I2 minus I3 is 8. Okay, now I2 minus I3 is 8. Now link equations. See, Ix is a current flowing into, which is the external branch of mesh 1. Ix is a current flowing into, which is the external branch of mesh 1. So Ix is I1. So link equations are Ix is I1. That is 4. Okay. Then fifth, see, Vx is a voltage across 3 ohms. Okay. Vx is a voltage across 3 ohms with this polarity. Vx is a voltage across 3 ohms with this polarity. But if upper terminal is positive with respect to down, then the resultant branch current should go down. Because in a passive element, current enter positive. Now resultant branch current should go down. If resultant branch current should go down, I1 should dominate I3. If resultant branch current should go down, then I1 should dominate I3. So Vx is 3 into I1 minus I3. Vx is 3 into I1 minus I3. Then only this polarity will come. Okay. So with this, all 5 mesh equations are over. All 5 mesh equations are over. Now I'm writing nodal equations. Chalo, nodals are everybody given. So if I write nodal, yes, I want everyone to see first node here. Okay, first node. This together is a single node. Please understand, this together is a single node. Okay, this current V1 minus 10 by 2, V1 minus 10 by 2. Okay, V1 minus 10 by 2. Okay, then this current minus Vx by 6, this current plus 8, this current, okay, V1 minus 5 Ix by 4, V1 minus 5 Ix by 4 equal to 0. This is 1. This is 1. Now second current, this current plus this current plus this current. This is Vx by 6. This is Vx by 6. This is minus 8. This is V2 by 3. V2 by 3 equal to 0. Okay, that is Vx by 6 minus 8, V2 by 3 equal to 0. Okay, now link equations. What are the link equations? See, Ix is a current flowing right side. Ix is a current flowing right side, but Ix is 10 minus V1 by 2. So Ix is 10 minus V1 by 2. That is equation 3. And I'm writing the last equation here. See, Vx itself is V2 because Vx is the voltage across 3 ohms, but this is taken as reference. This branch voltage across 3, it's nothing but V2 now, so Vx is V2. Vx is V2, that is 4. Vx is V2. Look at all the equations, please. Everybody look at all the equations. Okay, everybody. Chalo, with this, I'm going to next column. Let me see how many will again do this. Okay. Again, challenge is just write. Just write. Okay. Mesh and nodal equations. Nodal equations. I'm not asking you to solve by any means. Okay, but the challenge is you should write this mesh and nodal equations, which is more challenging here. Okay. Yes, more interesting and challenging here. Now this is 100 volts, 10 ohms, 20 ohms, 30 ohms, 40 ohms, V naught, 5 amps, 6 I naught. This is I naught and this is V naught. Again, in this problem also, there are two dependent sources. Okay, one is a current dependent voltage source, that is 6 I naught, and there is a voltage dependent current source, 8 I naught. Here also, I'm just asking you to write measure nodal equations, sir. Nothing to solve. Okay, this 40 ohms, let us write this side. Okay, chalo. Here also, I'm just asking you to write measure nodal equations, nothing else. Now, again, how to start? See how many nodes, how many branches, and how many meshes. First, let us argue, sir. So, if I observe, this entire thing is one node. This is 2, this is 3, this is 4, and this together is only 5. This together is only 5. Okay, nodes are 5. Branches 1, 2, 3, 4, 5, 6, 7, 8. Branches are 8. Okay. Meshes. Obviously, 4 meshes are there. Okay. This is I1 clock, I2 clock, I3 clock. Okay. This is I4 clock. So, there are 4 mesh equations. So, when it comes to mesh equations, yes, there are 4 standard. Yes, there are 2 link. 4 standard plus 2 link. 4 standard plus 2 link. Okay? Why 2 link? Yes, because there are 2 different. So total 6 equations you should get in mesh. What are the link? Link are the link equation between dependent parameter and mesh currents. Dependent parameter and mesh currents. Now when it comes to nodal, yes, though there are total 5 nodes, simple node only 1 neglected, but remaining 4 principal. In that one I will take reference. Let this be V1, let this be V2, and let this be V3. Okay, let this be V3. Okay, let this be V3. Okay. So here again total how many? Total 5 nodes. Okay, in that one simple you neglect. So 3 standard. Okay, let's 2 link here also. Total how many? 5. Okay, so link is the link equation between dependent parameters and node voltage. Dependent parameters and total. Yes, in mesh analysis. In mesh analysis there are 6. In node analysis there are 5. In mesh analysis there are total 6 and node analysis there are 5. So total 11. So try sir immediately. I'm giving you only 5 minutes. Those who can write such level, you are ready to start theorems now. Those who can write these equations correctly, now the basics are over. Then the applications and theorems will start now. Yes, I'm doing now. Everyone should see this level. If you can do, everything is done, sir. Okay. That is the reason I'm giving you time. Those who do what I say, they will be happy. Children mesh analysis. First mesh. Now watch this, please. Okay, I'm starting from here. Okay, I'm starting from here. Okay. Minus 100 plus 10 I1 plus 10 I1 plus 30 into I1 minus I2 into I1 minus I2. Super mesh open. Open minus 6 I0 minus 6 I0 plus 40 I4 plus 40 I4 equal to 0. Okay, minus 100 10 I1. Now this you should not go because there is a resistance here, that is not a super mesh. 30 into I1 minus I2. Super mesh now because we don't know the voltage. Now I will go right side, but no element. Again current source, again super mesh. Again go here. Minus 6 I0 plus 40 I4 is 0. Second equation I'm starting from here. 30 into, okay, I'm writing it here. Yes, 30 into I2 minus I1, okay, plus 20 I2, 20 I2 plus 6 I0 equal to 0. Okay, 30 into I2 minus I1 plus 20 I2 plus 6 I0 is 0. Okay, 30 into I2 minus I1, 20 I2 plus 6 I0 equal to 0. Third difference, I1, I3. So simply I1 minus I3 equal to 8 V0. 8 V0. Then another link, I3, I4. I3, I4, but resultant is going up now. So I4 minus I3 is 5. I4 minus I3 is 5. Is 5. Okay. Then also here, I0. Yes, we can also say the link equations I'm writing here. See, I0 is I1 minus I2. I0 is I1 minus I2. That is 5. Okay. See, I0 is I1 minus I2 because the resultant branch current is going down. That happens only if I1 dominates I2. So I1 minus I2. Then automatically what is V0? V0 is 28. V0 is 20 I2. That is 6. Okay. So all together, these are the 6 equations. First you see them. Everybody. Minus 100, 10 I1, 13 to I1 minus I2. Minus 6 I0 plus 4 I4. 13 to I2 minus I1, 20 I2 plus 6 I0. I3 minus I1 is 8 V0. Sorry, I1 minus I3 because you're going down, I1 minus I3 is 8 V0 and I4 minus I3 is 5. I0 is I1 minus I2, V0 is 20 I2. V0 is 20. Okay, now I'm going to nodal. Everybody watch nodal now. Yes, nodal. See first equation. This current plus this current plus this current is 0. So this is V1 minus 100 by 10. Okay. This is V1 minus V2 by 20. V1 minus V2 by 20. Okay. And this is V1 minus V3 by 30. V1 minus V3 by 30. V1 minus V3 by 30 equal to 0. This is equation 1. Okay. Second equation, V2 minus V1 by 20. V2 minus V1 by 40. Okay. V2 by 40. V2 by 40. Shoot through. Okay, shoot through and sum of these three currents. Minus 5 plus 8 V0 plus V3 minus V1 by 30 equal to 0. That is second. Okay. This is nothing but V2 minus V1 by 20, V2 by 40, shoot through minus 5 plus 8 V naught plus V3 minus V1 by 30. Okay, that is second. Then what about the third difference equation? Because this is a supernode, na sir. That is the reason. See why this second equation came like this. Everyone should observe. It is a supernode because there is a dependent voltage source between two principal nodes. This current I wrote V2 minus V1 by 20. This current I wrote V2 by 40. But what about this current? We don't know. Nah. So this current is sum of 1, 2, 3 currents. Minus 5 plus 8 V0, V3 minus V1 by 30. Then we got the total current. Then difference. V2 is more positive than V3 by 6 I0. So V2 minus V3 is 6 I0. So V2 minus V3 is 6 I0. That is equation 3. Okay, V2 minus V3 6 I0. Link equation. Link equation. What is I0? Yes, I0 is clearly, yes, I0 is clearly V1 minus V3 by 30. V1 minus V3 by 30. Because it is going down. That is 4. And the last link equation I'm writing here. Okay. Then V0 is simply V1 minus V2. V0 is simply V1 minus V2 because V1 is more positive than V2 by V0. That is equation 5. Okay, everyone look through these equations, please. Of course, these are nodal equations here. The green color are mesh equations and the yellow color are nodal equations. So everybody see now, we completed the complete chapter 2 also. Chapter 2 was very small but very powerful. Such big networks no one will give you, sir, but in IES conventional this level is required. Actually, these two last problems, this problem and this problem are IES conventional problems only. And there originally he was asking to prove Telighan's theorem, law of conservation of energy, which is very, very big problem. But in that, doing such mesh and nodal equations was mandatory. So these problems come in IES conventional level. So those students who clear prelims, na, sir, for them it is required. But in GATE and IES also, here and there, if you are confused in solving, you use mesh and nodal effectively. That is my suggestion. Don't worry, if you are good in mesh and nodal, na, sir, you can solve anything. That is guarantee. But which technique to adapt where, that will give shortcut. So yes, now we will start theorems. Okay, now we will start theorems. Okay, everybody. Yes. Okay, okay. I am not asking you to write, sir. It's only check. Yes, some student wrote. Correct. Again, anonymous Saturday. I don't like that name. Sai Sandeep told, sir, why can't we write about outer loop equation? No, sir, it is not about just writing KVL. Sai Sandeep, raise your hand. Sai Sandeep, raise your hand. Sandeep, see, it is not about writing KVL, whatever way you write. There are so many possible KVLs. KVL, it is satisfied in a mesh, in a loop, anywhere. But we are following a system. The minimum number of KVL equations to solve. See, if you keep on writing KVL in any path, then you are writing loop equations now. Loop equations cannot guarantee convergence in minimum set. Mesh equations will guarantee convergence solution in minimum set. Please, sir, everybody listen to this. Sandeep question, what he told is very good. Sir, why can't we write in the outer loop equation? Sir, we will write only super mesh if there is a current source as a common branch. Why? Because mesh equations are the minimum KVL equations to find everything. Suppose as Sai Sandeep told, if I write outer loop, it won't guarantee convergence solution. Please understand, writing equations, hundreds of equations you can write because there are so many loops here. But writing the minimum equations to get convergent solution is a challenge. Na? So that is why mesh analysis is important with minimal equations to get everything. But loop equations cannot guarantee you that. Okay, na? Okay, understood. Sai Sandeep, understood? Okay. Sandeep, understood? Raise your hand. Sai Sandeep. Okay. See this Bimalendu Swine. Who is this? Raise your hand. Bimalendu Swine, you don't ask such questions. You never ask such questions. Network will get 20 classes, 30 classes. Don't ask such questions. I will remove you from the group. We are doing our best to give you the best. Understand the problem from our side and your side also. Because of this online Corona, Nasar, it has devastated the system. You understand that first. You are also a BTech student or completed, I don't know. You are having classes in the college. You are doing this. What to do, sir? If it is an on live class, the clarity and the exposure we give is tremendous. But here, what to do? What to do? You tell me. Even this technology, I am learning for the first time. Sitting at home, back pain, and writing this on this. It's like even I am not feeling the greatness. Just writing my notes. I am feeling like I am writing my notes. If it is a class, live class, you come to my class, offline class. How transparent and how entertaining it will be. Ask my students. Understand, sir, we are doing our best, but don't say, sir, how many days it will take, how many classes it will take. Don't ask like that. You want to shall I teach you in 4 days? Okay, Bimlin, shall I complete? I have the ability to complete in 4 days. Shall I do that? Shall I do that? So much data I'm giving. We are still in second chapter, and so much content I'm giving, so that you need not refer any textbook in your life. You need not refer any material in your life. I told you. You read my notes thoroughly. You will have enough confidence to face the exam, and you will not even miss 1 mark. That is my challenge. And we are still in the second chapter and we are doing so much. And you are saying, sir, how many classes it will take? See, third time you are asking this question. I told the students, if you are interested, you come. Or if you don't want me, also you tell me, I will stop. Let other faculty teach. Arey, please understand, we want to do our best. But meanwhile, you prepare. Now, why are you worried about syllabus? Does syllabus completion give rank? I ask this question to every student here. Does syllabus completion give rank? What does it mean, sir? Syllabus completion means over. Day to day, read along with us. If I give 10 problems today, 20 problems today, 30 problems solve, you do day by day, be perfect in that. Why are you worried when syllabus is going to complete? What is that maza you get? Syllabus completion means you will get first rank. Do along with us. Don't think that once syllabus is over, then you will sit all together and read. How many subjects are there? You cannot read all together in 1-2 months also, even if I complete the syllabus now. So do along with that incremental daily 2 hours, 3 hours, whatever time you get, do that. Okay, don't ask such questions when syllabus will be completed. Otherwise, I will complete in one day. And I know how to even satisfy you in one day also. Nodal equation to these doubts I will tell you at last. See, Bharat, at last you asked us. We will explain. Don't worry. Okay, Bharat. After 10:30, please ask me. Okay, Bharat. Okay. Sai Sandeep. Okay. Yes, sir. Yes. Yes, even ice training. See, this anonymous attendee told, sir, ice training, sir. That is what, sir. Even for me also, we are never used to this technology, sir. But we are compromising. What to do, sir? Even that the corona has done so much devastation. What to do? Everything has changed. Classes would be so entertaining. Physically we are active, mentally we are active. What to do? But still we have to adapt. What nothing can be done now, sir. Even second dose my vaccination is not over, so we are all no problem, it's fine. I don't mind. You need not say sorry. Don't worry, but please cooperate, sir. All of you should cooperate with me. Okay, so all of you please cooperate. Last after completion now, sir, I will share my personal notes also, books also. Okay, we will do everything, don't worry. Okay, no need to say sorry. I don't want to hurt anyone also. But what to do, sir? Really, even I am not getting the real maza, sir. Offline classes, na, sir. In Ace Academy, 400, 500 strength, sir. But we used to get the full maza because students are so focused, so interested. As a teacher, I used to get full satisfaction, sir. But what to do, sir? Here, it is like I am passive. I am not able to see so many. If I turn on camera with everyone, na, sir, that internet speed is going down. Otherwise, even all 200, 300 students, I want to see them in their eyes and teach, but it is not happening here. Chalo, okay, no problem. Everybody, chalo, we completed 2 major chapters, sir. See, from first day until now, if you are perfect, then fundamentals of DC circuit analysis is over. And same way we will do even AC steady state also. Their AC phasors will come. Okay, J operator will come, impedance concepts will come. So, but techniques are same. That is why, sir, those who missed any classes also, until today's notes, you by heart, sir, by heart, literally read 10 times, 2 times, and all the problems do again without seeing. Resistor reduction techniques. We will do more tough problems also, sir, and keep asking doubts. I will give my WhatsApp number on the last day. Then directly you can contact me also. Put a message, put your doubt, I will reply. Okay, because even now some back students are giving me very good doubts. Good doubt I am replying, other doubts I am referring my notes. Okay, chalo everybody, let us go to network theorems. Okay, now yes, now we are going to chapter 3. Yes, this is chapter 3. DC network theorems. DC network theorems. There are total 10 theorems. Okay, there are total 10 theorems. Okay, there are total 10 theorems. Okay, like force transformation technique, superposition, then Thevenin's, Norton's, maximum power transfer, then Theligans. Okay, then after Theligans, reciprocity, Milliman's, compensation, and substitution. See, all are important, sir. Again, I told you, sir, in competitive exam, there is nothing like important or unimportant. Even in GATE 2018, for example, substitution theorem BT gave, sir. And the student who know the trick, na, sir, he got it in 30 seconds. And the student who don't know the trick, na, sir, he wasted 5-10 minutes to solve by normal way. That is why, sir, even substitution theorem, even a small Milliman's theorem will be so powerful. But which theorem, where to use, the techniques I will teach you. And as you practice, you will get that confidence. Don't worry. See, initially, first time reader will be so confused with all the theorems. But I'm telling you now, as you practice, you will come to a stage to tell, sir, here Milliman's is faster. Sir, here Thevenin's is best. Okay, sir, here reciprocity is very easy. Like that, you will come to that justification. The best is experience. Experience means practice. Okay, that is why you read my notes. All models will be there, sir. You need not refer anything after my notes. Only thing I recommend is keep practicing IS bits, gate bits, and write exams, offline, online exams. Whenever you are free, keep on writing them. Any subject also. Suppose your preparation in English is over, Maths is over, suppose analog is over. Do that, sir. Exams you keep writing because you will know the truth. How much I am still failing, where I am weak, am I able to get good rank or not? That justification and correction will come. Okay, so do that, write exams. So now, sir, I'm going to DC theorem. So I'm starting with theorem number 1. Okay, chalo, theorem number 1. This theorem number 1 is, yes, source transformation technique. Source transformation, okay, technique. Source transformation technique. Okay, source transfer. I use this abbreviation called STT in my notes. See in my notes, wherever you write STT means source transformation technique, like that you remember. What is this source transformation technique? Simple, sir. See, an ideal voltage source in series with resistance between two terminals. Okay, an ideal voltage source, okay, in series with resistance between two terminals can be simplified into ideal current source in parallel with the same resistance across same two terminals, can be converted into ideal current source in parallel with the same resistance across the same two terminals. Okay, but what is the value of this current according to Ohm's law? This I is V by R. According to Ohm's law, this I is V by R. Okay, I is V by R. And what should be the current direction? Upwards only. What should be the current direction? Upwards. Okay, current direction should be upwards. Okay, see what I want to say is, everybody, what I want to say is, yes, yes, everybody, please listen. See, voltage source in series to resistance can be converted into current source in parallel with resistance. Okay, voltage source in series to the resistance can be converted into current source in parallel with resistance. Okay, what is this I? I is V by R. But what should be the direction now? See, the direction should be such that the performance of both networks are same. For example, if you connect any passive element between AB, for example, if you connect any passive element between AB, this source will drive current from A to B na? Yes. If you connect any passive element between AB, this voltage source will drive current from A to B. Okay. Similarly, if you connect any passive element between AB, this source also will divide and allow the current from A to B. Yes, this source also will divide and allow the current from A to B. So that is why this direction is correct. So wherever plus is there, up arrow, minus is there, down arrow. Okay, tail of the arrow. So voltage source in series with resistance can be converted into current source in parallel with resistance. Now vice versa also, vice versa. Also vice versa. Vice versa. Now even current source in parallel with resistance. Yes, please understand. Current source in parallel with resistance across two terminals. Okay, current source in parallel with resistance across two terminals can be converted into voltage source in series with the same resistance across two terminals. Okay. Now this voltage value V equal to IR. It is an Ohm's law based reduction. V equal to IR. V equal to IR. But what should be the polarity of the voltage? V equal to IR. But what should be the polarity of the voltage? Okay. Now see, this current source will divide and allow the current from B to A. This current source will divide and allow the current from B to A. Okay, this current source is dividing and allowing the current from B to A. So if I put the same passive element, this voltage source will drive current from B to A. So this should be plus and this should be minus. Okay, this current source will divide and allow the current from B to A. So this voltage also will drive the current from B to A. Okay, that is why, yes, that is the concept. So wherever head of the arrow is plus, tail of the arrow is minus. Okay, now, now sir, first problem. First problem. Find current I using source transformation technique. Okay, listen to this question, sir. Find the current I by using source transformation technique. Theorems are very entertaining, sir, very easy also. Some of them are challenging, but learn all the tools. Mesh and nodal also we completed. Any problem we can do, but we will use them only if necessary, not everywhere, because mesh and nodal will take time. But here we are learning powerful theorems which will save a lot of time. Okay, my question is determine current I by using source transformation technique. Everybody see the question. Notes we are sharing, but only take rough papers, pen, pencil, and do only practicing problem. Okay, practice like work. Okay, don't worry. Notes, however, we are sharing, sir. Don't worry. Don't write also. Concentrate more when we are explaining and write a rough paper and scribble it. Chalo, now listen. See, find current I using source transformation technique. Okay, find current I by using source transformation technique. Okay, na? Okay, now listen, everybody listen. See, source transformation technique is a reduction based on target. Okay, na? Source transformation technique is reduction based on what? Based on target. So your target is current I into ohms branch, na? Yes, your target is current I into ohms. So don't disturb this branch. Source transformation technique is a reduction based on target. So your target is current I into ohms. So don't disturb 2 ohms. Okay, without disturbing 2 ohms, rest of the network you can do source transformation. Okay, now listen. So with respect to the same 2 ohms, okay, your voltage source in series can be converted into current source in parallel. Okay, so 20 volts in series to 1 become 20 amperes in parallel to 1. Yes or no? Because plus is up, arrow is up. Okay. Similarly, here also 27 volts is in series to 3. Yes, 27 volts is in series to 3. Becomes current source in parallel to 3. But see here, this is 3 ohms. But what is the value of current? I is V by R. V by R. 27 by 3 is how much? 9 amperes. And this current is going down. Current is going down. Current is going down. So 20 volts in series to 1 becomes 20 amperes in parallel to 1. 27 volts in series to 3 becomes 9 amperes in parallel to 3. Okay, and this is current I want, and this is current I want. Okay, 20 volts in series to 1 becomes 20 amperes in parallel to 1. 27 volts in series to 3 becomes 9 amperes in parallel to 3. Okay, and this is current I. So now again, sir, current sources in parallel, we can add them. See, at this junction, 20 amperes is entering, 9 amperes is leaving. At this junction, like KCL, 20 amperes is entering, 9 amperes is leaving. So 20 amperes entering, 9 amperes leaving is like 11 amperes entering, is like 11 amperes entering. Yes, 20 amperes entering, 9 ampere leaving means it's like 11 amperes entering. And here, these three are parallel. That passive elements don't disturb. Passive elements don't disturb. Over. Now I can happily do current division in 3 branches. We know this formula, sir. Yes, we know the current division formula. We know the current division formula. Okay. So in that regard, this current is total current into product of remaining two, 3 by sum of products. 2 plus 6 plus 3. It is finally 3 amps. It is finally 3 amps. These are voltage source in series to current source in parallel, voltage source in series to current source. But here why I took arrow down? Because current is going down by 27, arrow down. Then two current sources in parallel, we can lump it. Two current sources in series is violation of KCL, but two current sources in parallel, no problem. 20 entering, 9 leaving, 11 entering, and 1, 2, 3 parallel. So current division. This current is total current into product of remaining two by sum of products. Okay, product of remaining two by sum of products. So it is finally 3 amps. Okay. Now, sir, this is a gate 1 mark bit. So everyone should do this. Now I'm giving you 1 minute. See, he gave like this. The network between XY is like this. Ten volts 2 ohms, 8 volts 2 ohms, 6 volts 3 ohms. Okay, 12 volts 6 ohms. If the network between XY can be simplified into simple voltage source in series with resistance. Simple voltage source in series with resistance. What is the value of V and what is the value of R? So 1 mark wait. If the network between XY can be simplified into simple voltage source in series with resistance, what is the value of V and what is the value of R? Only 1 minute, please. Okay, done. Chalo. Yes, my answer you see now. Okay. If this network between X and Y can be simplified to this, what is VAR? Directly I will do now. Listen, everybody. See, this 10 volts in series to 2. Okay. I'm writing the solution directly. Let me remove this. Okay. This 10 volts in series to 2 becomes 5 amperes in parallel to 2. And this 8 volts in series to 2 becomes again 4 amperes in parallel to 2. So here 5 amperes in parallel to 2, here 4 amperes in parallel to 2. Both currents are upwards. So 5 amperes and 4 amperes upward, total become 9 amperes upward. 9 amperes upward, directly I'm writing. And 2 parallel become 1. 2 parallel become 1. This is the first part. This is the first part between these two nodes. Here interesting, sir. 3 by 2, 2 amperes up, 3 in parallel. Now come to the bottom part. 6 volts in series to 3 becomes 2 amperes in parallel to 3. And here 12 volts in series to 6 becomes again 2 amperes in parallel to 6. But here 2 amperes is up and here 2 amperes is down. Now 2 amperes up, 2 amperes down is like 0 amperes. Now 0 ampere current source is like open circuit because current source internal resistance is infinity. So 0 ampere current source means open circuit. But 3 and 6 parallel become 2. 3 and 6 parallel become 2. Direct steps are exam style. See 10 by 2, 5 up, 8 by 2, 4 up, 5 up, 4 up, 9 up, and 2 to parallel 1. Here also 6 by 3, 2 up, 12 by 6, 2 down. 2 amperes up, 2 amperes down is 0 amperes, and 6 in parallel to 3, 2. So the final step will be yes, 9 volts in series to 9 volts in series to 3 over. So this is the answer. This is the answer. Okay, now everybody? Chalo. Take your time, sir. No problem. Take your time. In doubts, you ask at last time. 10:30, I will stop. Okay, 10:20, I will stop. Ask doubts. Some students may have classes, etc. 10:20, I will stop, and 10:20 onwards. Those who have want doubts, you have to stay, sir, please. Okay, chalo. Now this is IS objective. IS objective. What is V naught? IS objective. What is V naught? This is 2 ohms. 2 ohms. 9 amperes. This is 5 amperes. This is 4 amperes. 2 ohms. 4 ohms. 40 volts. Chalo, my question is, yes, what is this V naught? Chalo, sir. Only IS objective. What is V naught? Quick, 1 minute. What is V naught? Okay, over. See here. See, I need V naught across 4 ohms. See, though there is a voltage source in series with resistance, see, though there is a voltage source in series with resistance, and I can convert into parallel current source in parallel to resistance, but you should not do, sir, because this is the target element. Source transformation is a very simple concept, Ohm's law reduction, but target is important. See here, the target element itself is 4 ohms. You cannot disturb. See, even in the first problem, this 2 ohms target you should never disturb. Even the second problem, the terminals XY are our target. But in this problem, V naught is a voltage across 4 ohms. I know it is in series to 40 volts. You may say, sir, 40 volts in series to 4 can be converted into 10 amperes in parallel to 4. No, no, because target you should not disturb. But remaining non-target elements I can disturb. See, here current source in parallel become voltage source in series. Okay. Yes, here current source, see the left side, current source in parallel become voltage source in series. Okay. How much is voltage? 10 volts. Arrow up plus up. 2 ohm series. Here 9 amperes in parallel to become 18 volts in series. 9 twos are 18 volts and right side positive. And this is 2 ohms. Here also current source in parallel become voltage source in series. Okay, voltage source P equal to IR 8 volts and this is 2 ohms. Okay, 8 volts and this is 2 ohms. And here again, yes, voltage source in series. This is target that you never disturb. Okay, that you never disturb. Okay, na? Okay, this V naught you should never. Okay, we will find it. But these all non-target elements I can lump them. See, I am lumping all the voltage sources starting from here to here. Now I'm traveling clock. See, I'm traveling clock. For example, if you are traveling clock, minus to plus is rise. Again, minus to plus is rise. Plus to minus is drop. Minus to plus is rise. So rise 10, rise 18, rise 28, rise 28, drop 8, rise 20 plus rise 40. Overall rise in voltage is 60 volts in clockwise direction. Yes or no? See, rise 10, rise 18, rise 28, drop it. Rise 20, rise 40, rise 60. Yes or no? Rise in 60. Okay. So this is 60. And then 2 are non-target, that is 6 ohms. But this 4 ohms I will never disturb. Okay. This 4 ohms I will never disturb. And this is the polarity of voltage is asking. No common sense. See, practical current direction driven by the source is clockwise. Now, practical current source driven by the source is clockwise. But in a passive element, if really current enter right side, this should be positive, but it ulta. So V naught is so voltage division rule minus of total voltage into same is 4 ohms by sum is 4 plus 6 10. So it is minus 24 volts. Why minus came? See, because this source is driving current clockwise. And if current is entering right side, actually right side should be positive, but it came ulta. So V naught is minus. Okay. Okay, sir. We'll take a break. Yes, it is 8:45. 9:15 come back. We will discuss more. Okay, 9:15 come back. Yes, everybody. Okay, look at the last column. I did source transformation. Everybody raise your hand. Can you see me? Can you listen to me? Some students left. They need to log in back. Yes, now increasing, number is increasing. Please come back, sir. Don't log off. You just hold the screen. Okay, now, sir. Yes, we are doing SWOT, source transformation technique. Okay. So now let us go to the next column here. Okay. Now my question is find current. Okay, find current Ix by using source transformation technique only, please. Okay, find current Ix by using source transformation technique only. Find current Ix by using source transformation technique. Find current Ix by using source transformation technique. Okay, now find current Ix by using source transformation technique. Okay, yes. Now see, let me do this problem. Find current Ix by using source transformation technique. Now this time current Ix is the current flowing through 1 ohm branch. So I cannot do source transformation to this branch, please. I know there is a voltage source in series with resistance. I know voltage source is in series with resistance. If I want, I can convert into current source in parallel with resistance. But I cannot do here because that is a target. Yes or no, that is a target. Okay. But right side, there is a dependent source. Can we do source transformation for dependent source? Can we do? My answer is yes. Source transformation is a simple Ohm's law based reduction. Source transformation technique is a simple Ohm's law based reduction. Yes, we can do source transformation even for dependent source. Now see here. Target branch I will never touch. That is what you have to remember, sir. If you disturb the target, then you are changing the question. So that is why this current Ix is the current flowing through this branch. That branch you should never disturb. Suppose if you disturb, you are changing the question. So now right side you see now. Right side there is a dependent current source in parallel with resistance can be converted into dependent voltage source in series with resistance. Now what is the value of dependent voltage source? V equal to IR. 2Ix into 2. That is 4Ix volts. Right side positive, right side arrow, right side positive, and 2 series become 4. 2 series become 4. Okay, so yes, dependent current source in parallel with resistance can be converted and voltage source in series with resistance. Okay, so 2Ix into 2, 4Ix volts. Okay, 2 series 4. Okay, now 2 series 4. Okay, this I lumped it, sir. So now again I will do source transformation again. See, target branch I will never disturb. That is for sure. Okay, target branch I will never disturb. This is something like 10 volts and 1 ohm. And this is my current Ix. But this side you see dependent voltage source in series with resistance. Dependent voltage source in series with resistance become dependent current source in parallel with resistance. Now I equal to V by R. I equal to V by R. 4Ix by 4 is Ix amperes. 4Ix by 4 is Ix amperes and current is going down and 4 parallel become 2. 4 parallel become 2. Okay, please understand. Okay, so 4Ix in series to 4. So I is V by R. I is V by R. Okay, I is V by R. That is Ix amperes and 4 parallel become 2. Again, what I will do, this side I will not disturb. Okay, this side I will not disturb. This is still Ix. Now, dependent current source in parallel can be converted into dependent voltage source in series. Dependent voltage source in series. So, V equal to IR. V equal to IR. Okay, V equal to IR. Okay, and bottom is plus, and this is 2. Okay, so V equal to IR. Okay, now V equal to IR. Okay, so now I did all these things, sir. Now it's enough. Here what I did from here to here, dependent voltage source in series become dependent current source in parallel, but that 4 parallel become 2, I lumped it. And final step is this. Now I will happily write a KVL. Chalo write a KVL. If I write a KVL, minus 10. Okay, minus 10. Okay, this Ix is flowing in both 1 plus 2, 3. So 3Ix, 3Ix. Okay, minus 2Ix equal to 0. So Ix is 10 amperes. Ix is 10. Ix is 10 amperes. Ix is 10 amperes. So we learned one point that source transformation technique is also valid for dependent sources. Okay, now source transformation technique is also valid for dependent sources. Now this is another application question. Okay, gate 1 mark. So this is 10 volts, 2 ohms. This is 1 ohm. This is 2 amperes, 1 ohm. Okay, 2 amperes and 1 ohm. Okay. Now the question is determine current through diode. 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 Okay, na? Chalo, I'm doing this again. Everybody listen, sir. Actually, this is a non-linear network. Why it is a non-linear? Because diode is a non-linear device. It is a non-linear network because diode is a non-linear device. Okay, but still, with respect to diode, I can reduce the linear part of the network. With respect to diode, I can reduce the linear part. Here, directly Mesh nodal you cannot do, na sir. Though Mesh nodal we practiced so much, but without knowing the state of the diode, we cannot, because non-linear and also unilateral element. I told unilateral elements, the properties of such elements depends upon circuit condition. Yes or no? So here, without knowing the state of the diode, we cannot declare anything here. Okay, na? So in that case, what I will do with respect to diode, I will reduce the rest of the network. Now here, voltage source in series become current source in parallel. Okay, 10 volts in series to 2 become 5 amperes in parallel to 2. The 2 to parallel become 1. So no, 2 to parallel become 1. Plus up, arrow up. Now this branch you should never disturb. Yes, this branch you should never disturb. Similarly, current source in parallel. Here also current source in parallel can be converted into voltage source in series, but I will write first step here, then I will go there. Okay, so this is 2 amperes, 1. So here again, 10 volts in series to 2 becomes 5 amperes in parallel to 2, the 2 to parallel become 1. Here as it is, but target branch I am not disturbing. What is target branch? Where diode is there. Similarly, next step you see. Now this current source in parallel can be converted into voltage source in series. Okay, this 5 volts arrow up, plus up, okay, 1 ohm, but this target branch also 1 ohm and diode is there, that you should never disturb. And right side also, yes, voltage source in series, can be converted where V equal to IR 2 volts but plus up, and this is 1 ohm. So now sir, now with respect to diode, yes, now with respect to diode I can reduce the rest of the thing. Say I will travel clockwise from here to here. If you travel like that, drop 2, see, plus to minus is called drop, minus to plus is called raise, plus to minus is called drop, minus to plus is called raise. So drop 2 raise 5 is raise 3, drop 2 raise 5 is raise 3 volts, and this 1 1 1 become 3, and this is the okay na? See, drop 2 raise 5 is 3 and 1 1 1 3. So now I will declare diode is forward bias and ideal diode on state resistance is 0, because in my subject all ideal things will learn, sir. Your practical analog, sir, you will take drop of 0.7 volts if it is silicon like that, but here I will not take because I am teaching ideal circuit analysis. So ideal diode on state resistance is 0, it is forward bias, so automatically current through diode is 3 volts by 3 ohms, it is 1 ampere. 1 ampere. So source transformation technique is applicable even to solve non-linear unilateral device networks like analog, op-amp network, diode network, clipper, clamper. So many things you can at least do reduction in the linear part. At least you can do reduction in the linear part. Okay, na? That is very, very interesting here. So yes, please understand that. Okay, source transformation idea. Now I'm asking a very, very interesting question. Find current I by using source transformation technique only. Find current I by using source transformation technique only. Find current I by using source transformation technique. Try something, sir. I'm giving you 2 minutes. Try something very interesting problem. Find current I by using source transformation technique. Yes, very interesting, sir. See this problem where there is no direct voltage source is in series with resistance nor current source in parallel with resistance. Then what to do? I do something called as source shifting technique. Source shifting technique without any violation of KCL or KVL. See, sir, what I am doing. Very carefully watch. Very carefully watch what I am doing. See this current source here, 8 amperes is leaving now. I will write like this. Here 8 amperes is leaving and the same 8 amperes is entering here. And the same 8 amperes is entering. Okay. So this is 1 ohm, 1 ohm, 1 ohm and 1 ohm. Here also what I can do, voltage will split. The same voltage source, now I'm separately writing. So here you see, sir, see wonderful step I wrote. This step you have to understand. See what is the reason? Reason, sir. See at this junction, how much 1 ampere, sorry, 8 amperes is leaving. At this junction, how much current is entering? 8. So here also at this junction, how much current is entering? 8. At this junction, how much it is entering? 8. But here we injected it and then we removed it. We injected it and then removed it. Nothing added, na? Yes, source shifting without violating KCL. So finally, this is like leaving it, entering it, and here I injected it and I removed it. So net current added is 0. See a trick, how trick it is. Similarly, at this junction, with respect to this is plus 16. With respect to this is plus 16. With respect to this is plus 16. That means this 1 ohm is getting plus 16 with respect to this 2 ohms also is getting plus 16 with respect to this. So here also with respect to the same single node. Yes, this is all single node. This is all single node. This is getting plus 16. This is also getting plus 16. It is common minus means single node only. It is common minus single node only. So this is plus 16. This is also plus 16. So here 8 is leaving, 8 is entering. So here also 8 is leaving, 8 is entering. Here with respect to minus, yes, this is plus. Okay, 16. This is also plus 16. So I did not make 4 sources or 2 sources into 4 sources. Please understand. I did not make 2 sources into 4 sources. No, I did not do anything like that. I did not make 2 sources into 4 sources. But what effect we get by single source direct connection? What effect we get by single source direct connection is the same effect by writing separately. What effect we get by single source in direct connection? Okay, please understand. What effect we get by a single source in direct connection is the same effect we get by writing separately. Yes, is the same effect we get by writing what? Separately. That is the meaning here. That is the meaning. Okay, na? Yes, that is a very interesting concept, sir. Very interesting concept. Okay, na? Chalo. Now, once this step is over, na, sir, everything is easy, sir. Everything is easy. Okay. Okay. Now, see, this side current source in parallel can be converted into voltage source in series. Okay. Here also, okay, what is the value? 8 volts in series to 1. Okay, 8 volts in series to 1 because right side current plus right side. Here also, current source in parallel can be converted to voltage source. What is the value of voltage? 8 ones are 8 volts, left side positive. 8 volts, left side positive. 1. Okay. Here also, yes. Here also voltage source in series. Here also voltage source in series. Okay, I will write again. Okay, but 16 volts is left side positive. Okay. Yes. Okay, but here 1 ohm, only 1 ohm is there. That 1 ohm I will write. Good, until here it is okay. Then here this same wire connected, but 16 volts in series to 1, 8 amperes in 16 volts in series to 2 becomes 8 amperes in parallel. So here 8 amperes in parallel to 2, and here 1 is also there. Rest all is same, sir. Rest all is equal. astrology. But my target branch, I am not disturbing. See, target branch, I am not disturbing. You can check, sir. See, 8 ampere in C parallel to 1 becomes 8 volts in series to 1, right side positive. Okay. Here 8 amperes in parallel to becomes 8 volts in series to 1, left side positive. Okay. Then here 16 volts. Yes. And here again 16 in series to 2 becomes 8 amperes in parallel to 2. Okay. So until here we got. Okay. Now further if I reduce, see going raise 16, drop 8. So raise 8. It become raise 8. Raise 8. And this 1 1 become 2. 1 1 become 2. Okay. And here I'm closing this. Now here 8 amperes. Yes, 8 amperes in parallel to 2. This become 2 by 3. One ohm. See, sir, what I did. Everybody watch this. Okay, now? Until you are understanding, see, because this is plus 16 left plus, and this is minus 8. So overall 8. 1, 1, 2. Here also. But again, these current sources I will convert. Okay, again, these current sources. Yeah, this voltage source in series become current source in parallel. I will write direct step. This step also I will retain for one more time. But target I am writing at the bottom as it is. Now here what I did, 8 volts in series to 2 becomes 4 amperes in parallel to 2. Here also 8 volts in series to 2 become 4 ampere in parallel to 2. Both currents are left side now. 4 ampere, total become 8 amperes left side. And 2 parallel become 1 ohm. Okay, so now sir, last step I will write. Yes, last step I am writing. So finally 8 amperes in parallel to 1 becomes 8 volts in series to 1. And this again become right side, and this is it. So 8 volts, 1 ohm, 2 by 3 ohm, 16 by 3 volts. Okay, 8 amperes in parallel, 8 volts in series to 1. 8 amperes in parallel to 3 is 16 by 3 volt in series to this. I am writing a KVL anti-clock. So if you write KVL anti-clock, yes, KVL anti-clock plus 16 by 3. Okay, I into 2 by 3 plus I into 2 by 3. 2 by 3I plus 1 into I. This again is minus 8. This again 1 into I equal to 0. So if you take I common, 2 by 3 plus 1 plus 1, 2 is equal to 8 minus 16 by 3. So this if you take again 8 by 3, this also become 8 by 3. So I is 8 by 3 by 8 by 3 is 1 ampere. First step you see again everybody. Try to observe first step again, I will explain. So this first step is very interesting, sir, everybody, because here you observe this very, very interesting. Here 8 is leaving, 8 is entering. So here also 8 is leaving, 8 is entering. We neither added nor removed current. I did not make one current source into two current source, please. The same current source, I wrote separately the same effect. Here also with respect to this plus 16. So this 1 ohm here is getting plus 16, 2 ohms also getting plus 16. So here with respect to same node, yes, this 1 ohm is getting plus 16, this 2 ohms also getting plus 16. Here you write KCL, nothing is violated. Like here you write KVL, nothing is violated. You check it. Okay. So without violating KCL, KVL, everything is same. Now then all simple, sir, current source, etc. we wrote. This thing I think you can understand. Okay. So if you understood this procedure, Now I will give this challenging question. Okay, na? Chalo. My question is find current I by using source transformation technique only. Okay, find current I by using source transformation technique only. Okay, here are the values. Let me correct, sir. Here the values are, yes, this will be 3 ohms and this will be 6 ohms. 3 ohms and 6 ohms. So find that current I by using source transformation technique only. Find current I by using source transformation technique only. Find the current I by using source transformation technique. Okay, now see here, find current I by source transformation. Listen, sir. See here again, you know there is a current source in parallel with resistance. But can I convert this into voltage source in series with resistance? No, because there is a target. You cannot do that, sir. There is a target. See what I will do. I will not disturb the target first. Listen carefully. I will not disturb the target. This is I want. But rest of the circuit you see now. Everybody watch this. See here, with respect to same 18, this is plus 18. So I will write separately. So what I'm doing, I'm writing separately. Watch this, what I'm writing. This is the same node, but like I'm writing separately, not that I'm making two sources. Watch this step, critical step. I call this as source shifting. See, like in the previous problem also, with respect to this voltages, I wrote separately. Minus is common, so plus and plus 16, because here with respect to minus, plus 16 is coming. So same way, here also with respect to this, plus 18 is coming. So here also plus 18 left side, here also plus 18 right side. But this is common negative node. This is a common negative. And this is 2 ohms, 2 ohms, and this is 6 ohms, 3 ohms. Then again, yes. Now you see at this junction, 3 is leaving. At this junction, 3 is entering. At this junction, 3 is leaving. At this junction, 3 is entering. Okay. So here 3 is leaving. And at this junction, 3 is entering. At this junction, 3 is leaving. At this junction, 3 is entering. So at this node, did I add or remove any current? Nothing, because I injected 3 and I removed 3. So at this bottom node, I did not do any change. But here, from here, 3 is leaving. So 3 is leaving this. See, this node belongs to this. And left side node is this node. So that is a critical step, sir. Okay, neither I violated KCL nor I violated KVL. Now, once you know this, sir, very easy. Now, see what I will do. Now, these all are parallel. These all are parallel. I will lump them. And here also, between these two nodes, these all are parallel. I will lump them. So, what I will do? 18 volts in series to becomes 9 amperes in parallel. 9 entering, 3 entering is total 12 entering. 9 entering and 3 entering is total 12 entering. And 2 parallel become 1. Right side also. At this junction, 18 by 3, 6 is entering, but 3 is leaving. 6 is entering, 3 is leaving, is like 3 is entering. Okay, is like 3 is entering, and this 3 in parallel to 6 become 2. Okay. Then this 1 ohm is my target, which I am not disturbing. See what I did. See, between this node, see, actually this common node is this node only, sir. So here you can see, yes, 18 by 2, 9, 18 by 2, 9 entering, 3 entering, 12 entering at this node. This node is this node, 2 to parallel 1. And here this node is same as this node. So here 18 by 3, 6 entering, 3 leaving is 3 entering. And 6, 3 parallel 2. And when it comes to last case, yes, when it comes to last case. Now 12 in parallel to 1. In parallel to 1 becomes 12 volts in series to 1. Here also 3 in parallel to 2 becomes 6 volts in series to 2. And I need this current I. This current I, now KVL I will write, okay, simply let me write KVL. So if I write a KVL, because why I did again, see 12 in parallel to 1, 12 volts in series to 1. Here's 3 in parallel to 2 becomes 6 volts in series to 2. Arrow up, both arrows up, plus up. So KVL, minus 12 plus 4i plus 6 equal to 0, 4i equal to 6. So I is 6 by 4, 3 by 2, 1.5 amperes is the answer. 1.5 amperes. Okay, very interesting problem. Chalo. So with this, I covered all the models of source transformation. Okay. Chalo, sir. Now I am going to another big and powerful theorem 2. Yes, theorem 2. This is superposition theorem. Superposition theorem. What Watch this, sir, carefully. More powerful theorem, SPT. Superposition theorem, SPT. Now statement I am giving. In any linear active bilateral network. Okay. In any linear active bilateral network. Okay. Consisting of number of energy sources, resistances, etc. Okay, in any linear active bilateral network consisting of number of energy sources, resistances, etc. The effect produced in any element, yes, the effect produced in any element when all sources at a time, okay, when all sources act at a time is equal to sum of, yes, is equal to sum of effects produced in the same element when each source is considered separately or individually. Okay, in any linear active bilateral network consisting of number of energy sources, resistances, etc. Okay, in any linear active bilateral network consisting of number of energy sources, resistances, etc. The effect produced in any element when all sources act at a time. Okay, the effect produced in any element when all sources act at a time is equal to sum of individual effects when each source is considered individually. Okay, is equal to sum of individual effects when each source is considered separately or individually. Sum of effects. Okay, now so this is a additive property, sir. Superposition is additive property. So the mathematical meaning I will tell you. So first of all, if there is a network with so many sources, now, sir, and we are finding something, so better take each source separately, reduce faster, and add the effects. So there is a meaning. So take each source separately, find these individual effects, and then to take addition of all these effects, then you will get same answer. So what it will do, a complex network with multiple sources, it will subdivide into single source network. So in any linear active bilateral network consisting of number of energy sources, resistances, the effect produced in any element when all sources act at a time is equal to sum of effects produced in the same element when each source is taken individually. Okay, now that is the meaning here. That is the meaning. Okay. Now what is the mathematical meaning? Now see, this is a linear network. Okay, this is a linear network. Linear network. Okay. Okay, now suppose if I give an input x1 which is producing a corresponding output y1. Suppose I give an input x1 which is producing a corresponding output y1. Now if I scale this by factor k1, output is also scaled by factor k1. That is called homogeneity. Okay, if I multiply the input by factor k1, output also gets multiplied by factor k1. Okay, similarly, if I give an input x2, it is producing an output y2. And if I scale this by factor k2, output is also scaled by factor k2. Now if I give all together, now there is a superposition. Separately, you can add now all together. Like k1 x1 plus k2 x2, if I give all together, then the total effect also will be k1 y1 plus k2 y2. Like sum of individual effects is total. Okay, sum of individual effects is total effect. That is the meaning here. Now this is the mathematical meaning of superposition for two inputs. Suppose there are n inputs like x1 y1, x2 y2, x3 y3, xn yn. So if I play homogeneity by multiplying them with constants, proportionality, then if I give all together like k1 x1 plus k2 x2 like that, kn xn, you'll also get k1 y1, k2 y2 like kn yn. That's the meaning. That is the real meaning of superposition. Okay, now that is the real meaning of superposition. Okay, that is the meaning. Okay. So now in that case, everybody, yes, now in that case, now I'm writing the conclusion that superposition theorem is a combination of, okay, superposition theorem is a combination of, combination of superposition theorem is a combination of first linearity. Yes or no? Linearity. That is homogeneity. Linearity, homogeneity, proportionality. Then this I will write homogeneity. Linearity means Ohm's law. Okay, now Ohm's law. Homogeneity means proportionality and also additive property. Additive property. So that is the meaning, additive property. So superposition is a combination of all these three, sir. One is linearity, that is Ohm's law, homogeneity or proportionality, and also additive property. Okay. Yes. Superposition theorem is a combination of linearity, Ohm's law, homogeneity, okay, or proportionality, and also additive property. Okay, na? That is the meaning here. That is the meaning. Okay. So now I'm asking a question that the number of subcircuits to be solved while applying superposition theorem is dash. The number of subcircuits to be solved while applying superposition theorem is dash. Option A, sum of independent plus dependent source. Option B, difference between independent and dependent source. Option C, independent sources only. Option D, dependent sources only. The number of subcircuits to be solved while applying superposition theorem is dash. Okay. The number of subcircuits to be solved while applying superposition theorem is dash. Sum of independent plus dependent source. Difference between independent and dependent source. Independent sources only. Dependent sources only. Okay, now independent sources only. Dependent sources only. Okay. So answer is what? Answer is independent sources only. Yes, why? Because sir, dependent source alone cannot work, na sir. See, I will explain like this. See, in my subject, independent sources, circle symbol, dependent sources, diamond symbol, and passive elements are RLC components. Okay, na? See, first of all, dependent source cannot work on its own. Who can give energy to this also? Independent source only can give this energy, even to the passive elements. Then this fellow gets energy from independent source, then it becomes active. So who is the ultimate source provider? Yes, independent source only. The ultimate source provider is who? Independent source only. Okay, so please understand this. Yes, the ultimate source provider. The ultimate source provider is independent source only. Okay, that's the meaning. Okay, the ultimate source provider is independent sources only. Okay, answer is this. Then I'm asking another question. Okay, which of the following? Which of the following? Okay, which of the following electrical parameter? Okay, which of the following electrical parameter cannot be directly, which of the following electrical parameter cannot be directly evaluated by using superposition theorem? Which of the following electrical parameter cannot be directly evaluated by using superposition theorem? Option A, voltage. Option B, current. Option C, charge. Option D, power. Which of the following electrical parameter cannot be directly evaluated by using superposition theorem? Okay, my answer is simple, sir. Power. Why power? See, power is non-linear electrical parameter. Non-linear electrical parameter. Non-linear electrical parameters are power. Non-linear electrical parameter. So please understand, power is a non-linear electrical parameter and you cannot directly evaluate by SPT. See, all other things are our linear. Okay, the reason power is a non-linear electrical parameter. Okay, chalo sir. Now I am giving the first question. Okay, find current I. Find current I by using superposition theorem. Okay, now I'm giving the first problem. Find current I by using superposition theorem. So this is 10 volts. This is 2 amperes. This is 1 ohm, 2 ohms, 3 ohms. And I'm asking find current I by using superposition theorem. I'm asking find current I by using superposition theorem. Okay, find current I by using superposition theorem. See, now this current I is the current flowing in 2 ohms. Yes, this current I is the current flowing through 2 ohms, which is due to simultaneous action of both the sources. Okay, this current I is the current flowing through 2 ohms. This is due to simultaneous action of both the sources. Okay, but this current I can be determined by taking each source separately. Each source separately. Now, how many sub-circuits are there? 2 sub-circuits. Okay, step one. Step one. I will take 10 volts only. Okay, step one. I will take 10 volts only. I will open the current. Okay, this is 10 volts. This is 1 ohm, 2 ohm, 3 ohm. Let this be current I dash. Let this be current I dash. Okay, see, I take 10 volts, 1 ohm, 2 ohm, 3 ohm. I open this, let this be current I dash. Now, can current flow here? No. So, I dash is clearly 10 by 3 amperes. Now, step 2. Step 2, I will take 2 amps only. Okay, now everybody, I am taking 2 amps only. Okay, step 2, I am taking current of 2 amps only. Okay, this is like 1 ohm, 2 ohm, 3 ohms, and I will short this. I will short this and let this current be I double dash. Let this current be I double dash. Now, this 3 ohms is in series to 2 until here current is same. This 3 ohms is in series to 2 until here current is same. Then I can do current division. Then I can do current division. This current I double dash is total current into, okay, total current into opposite one by sum. That is 2 by 3. 2 by 3. Okay, because current source in series to element current is constant now. At this junction it will divide because these two are parallel. Voltage source is shorted, so 1 and 2 parallel. So this current is total current 2 amperes into opposite one by sum. So now according to superposition theorem, this total current I is I dash plus I double dash. 10 by 3 plus 2 by 3, 12 by 3. It is how much? 4 amperes. Answer is 4 amperes. Okay, answer is 4 amperes. So answer is how much? Clearly 4 amperes. Okay, now I'm giving another model here. Yes, everybody. Find voltage V by using superposition theorem. Okay, find voltage V by using superposition theorem. Yes, find voltage V by using Superposition theorem. Find voltage V by using superposition theorem. Okay, everybody, find voltage V by using superposition theorem. Okay, now find voltage V by using superposition theorem. Find voltage V by using superposition theorem. See here, the voltage V across 2 is due to simultaneous action of two sources. I will take each source separately and do. First, I will take 10 volts only. Okay, now watch this, please. I am taking first step 10 volts only. So if I take 10 volts only, okay, what I have to do with the current source? Open it, or open circuit it. Okay, so this is now 10 volts, 2 ohms, 1 ohm, 3. And let this voltage be V dash, V dash. Now, when each sub-circuit has only one source, NASA directly you should do. No need to do any procedure here. See, if you observe, from between this node and this node, these are parallel. 2 is in parallel to 4 now. See, this 2 is in parallel to 4. 2 is in parallel to 4 become how much? 8 by 6. That is 4 by 3. Okay, 2 in parallel to 4. Yes, 8 by 6, 4 by 3. Then I can do V. V dash is total voltage into same by some voltage division. After lumping that NASA, it becomes voltage division. Okay, so V dash will be total voltage into same by sum. Okay, V dash is total voltage into same by sum. Same is how much 2. Sum is how much 2 plus 4 by 3. So that is nothing but 6 volts. Okay, that is nothing but 6 volts. Okay. Now step 2. I am going to step 2. Now step 2, I will take this 5 amps currents only. This 5 amps only. So what I do with the voltage source? Short it. So this voltage source, I am shorting it. First I will take current source, which is 5 amperes. And this voltage source, I will short it. Okay, this is 2, 2, 1, 3. Okay, and let this voltage be V double dash. Okay, so this is 5, 2, 2, 1, and 3. Let this be V double dash. Okay, now let this be V double dash. Okay, I need this V double dash. Okay, now, so now in that regard, yes, in that regard. Now, if you observe, see between this node and this node, these two are parallel. Between this node and this node, these two are parallel. So 2 to parallel become how much? 1. So voltage will be same now in parallel system. So first, if I observe, these two are parallel now. See, these two are parallel. Okay, I will write the step like this. This current source is as it is. This is 5 amps. 1 ohm. 2 to parallel become 1. And let this be V double dash. Okay, now this 5 amperes will come. It will divide into 2 parts. Current division and Ohm's law. So V double dash will be, okay, minus of resistance into current through it. Current is how much? Total current 5 into opposite. Opposite is 3. By sum is 3 plus 2. 3 plus 2. So this will be minus 3 volts. See, first I took only current source, removed voltage sources, but these two are parallel now. 2 to parallel become 1, and same V double dash will appear here because in a parallel system voltage is same. But what I did now, this total current will come. First I did current division and Ohm's law. This current will be total current is 5 into opposite 3 by sum. This is a current division rule into resistance, but negative. Why it is negative? When this current source is driving current this way, in a passive element, actually this should be positive. In a passive element, this should be positive, but a K volta, so V double dash is negative. So finally, by superposition theorem, V is V dash plus V double dash. That is plus 6 minus 3 is plus 3 volts is a final answer. Plus 3 volts is a final answer. Okay, now? So now I will take doubts now, everybody. I will take doubts now. Those who have doubts, raise your hand. Tomorrow schedule will come, sir. Please confirm it. I think it is from 7 to 1. Everyone raise your hand. See, tomorrow schedule will be from 7 to 1. Is it okay for you? Is it okay? So mostly 7 to 1 will cover a lot of theorems, sir. Almost DC circuits we can complete. Tomorrow we will do that hard work and complete DC circuits. I will give breaks 2 times, small breaks, but we will complete a lot of syllabus tomorrow. Okay, na? Chalo, now first Shreyanshi. Those who are raising hand and I'm allowing you to talk, so talk quickly and come to the line and let us conclude. So many are there. Chalo, Shreyanshi, please, what is your doubt?
Sir, this last problem itself, after in first step, I wanted to know that how that 1 ohm came there, because in the initial
between this node and this node, these two are parallel, na? See, this is a single node.
No, sir. I was asking about the other 1 ohm because in the question it is 2 ohm, right?
Yeah,
No,
correct.
no.
This is 2. Okay, so what I did here actually this 2 become parallel 1, na? But in a parallel system, luckily voltage is same. That is the reason I'm taking that reduction.
Okay.
So 2 parallel become 1 like this, na?
Okay. Yes.
Okay, between the same 2 nodes. Okay, so
Yes,
this V double dash will appear here. Okay,
Okay, sir.
and then Ohm's law and current division. Okay.
Okay. Yes.
Okay. Then Ashish.
No doubt, sir.
No doubt. Huh? Okay, no problem. But tomorrow 7 to 1. Very good. Okay, chalo, Pratyush.
Hello, sir.
Tell me, Pratyush.
Sir, in the last problem of source transformation technique, sir.
Okay. This problem.
Sir, yes, sir. Sir, after doing source transformation, there after 18 and 2 ohms, this 2 ohms is then in parallel in the series with 18 volts. Sir, can't we take a 2 ohms in parallel with the same 9 amperes, sir? Like that, in that way, we can't do, sir.
No, you do, but finally further reduction will give this step only, na? See, first you are telling only one step, like 18 volts in series to become 9 amperes in parallel to 2, na?
Yes, sir.
But again, the 2 parallel become 1, na?
Yes, sir. Sir, my doubt is what current direction we have to take in that 9 amperes, sir?
It is entering this node only, because see, left side positive, na?
Yes, sir.
Means current is entering the node.
So from down to up, sir, we should take.
See, your understanding, yeah, down to up only, but I conclude in a simple way. This node is same as this node, na?
Yes, sir.
This node is same as this node, na? So here entering means here also entering, na?
Yes, sir.
This 3 is already entering, 9 is entering, total 12 entering, na?
Yes, sir.
Like that.
Okay, sir. Okay, done, sir. Thank you, sir.
You practice, you will come. No, correct. You did correct, right? Then Avinash.
Hello.
Avinash.
Sir, source transformation is applicable for inductor and capacitors also, sir, or not?
100%. Their impedance concepts will come. Their impedance. When I teach AC steady state, there I will teach you. In AC steady state, impedance will come. Later, for any function, Laplace transforms will come. Everywhere we can do.
Okay, sir.
For any function, sinusoidal, triangular, square also, in network functions chapter, I will do that.
All right, sir.
First, we are doing DC. So for DC, only resistor is working. Inductor short, capacitor open. Later in AC steady state, sinusoid, phasor notation, impedance also we can do. Later for any signal at any function, we will do network function style. Laplace domain also we will do.
Okay, sir.
Okay? Right. Then next, Ramakrishna.
Yes, sir. Hello. Good morning, sir.
Tell me, Ramakrishna.
Sir, can you explain this same slide 3 ampere, how you divided?
See, for example, okay, I will take like this. This is a pink node. The pink node is the pink node here.
Yes, sir.
And similarly, okay, this is something like, yellow node, okay, or orange node. I will take orange node here is orange node here. Okay, na?
Yes, sir.
See, at this pink node, 3 amperes is leaving. And orange node, 3 amperes.
Okay. Yes, sir. Got it. Understood, sir.
3 entering, 3 leaving, like that.
Yes,
Okay?
sir.
Right.
Once last step, sir. Last slide.
Today's last slide.
Yes, sir.
Tell me what you doubt.
So here in this first green color diagram, so it is shorted. Voltage source is shorted, no, sir. So current passes to
Listen. Suppose
can that be happen?
Listen. Suppose if this 1 ohm is not there, then it is a dead short circuit across passive system.
Okay.
If 1 ohm was not there, then it is a dead short circuit across parallel, then current cannot flow. But actually this 1 ohm is there now, it is creating a potential difference between this point and this point and this point and this point now. They become parallel. So that is why short circuit completely in parallel to passive element is redundant.
Okay,
This
sir.
1 ohm here will create a potential difference now.
Yes, sir.
Become parallel. Okay, na?
Okay. Thank you, sir. That's it. Thank you.
Yes. Bimalendu Swain.
Yes,
Tell me, Bimalendu.
sir, we can win in this circuit only. Sir, here we are always means not violating that element where we are
Right,
finding
correct.
response.
Your doubt again, very correct. See, luckily in this problem only, actually target element and target terminal should not change. But because luckily these two are parallel, and moreover here we are finding voltage only na, and in a parallel system voltage will be same na.
Sir, okay.
That is the reason only I did. Suppose the question was in these two. Suppose you find the current, he would have said. Then I should not do that.
Okay. Or next, sir.
Tell me.
Next, sir. We can means that if I am considering that you are making that 2 volt parallel. Yes. I am finding by that 3 ohm is parallel to 5 ampere.
No, 5 amperes and this reduced to 2 ohms and 3 ohms all are parallel.
Means I can externally connect any type of wire so that that response will be not changed. Means that
in a parallel system voltage is same.
Means I am extending that 5 ampere can be other thing can be changed, but that response element will be not changed, not valid.
Yes, it is understood. Right.
Okay. Means
Like in a house also, you are always connecting so many fans, lights, but voltage is always constant, huh?
Okay. Sir. And in the previous example, sir, that is a source transformation, that is 18 volt.
Okay.
Sir, here we are getting that. Let's suppose the node potential is 0 volt. The downward node potential is 0 volt. Then it potentially, this potential also, when we are short circuiting, then also potential is 0 volt.
No, it is the same node as a reference I am taking. Suppose this is like reference. Okay, then this entire thing is the reference.
Yes, sir. And when we are means previously that point potential which is 18 volt.
With respect to this is 18. Top one is 18. So here
is 0 volt.
And this is 18.
Okay, means we can transform any type of.
Any number of times, but with respect to common reference and the elements, what voltage. Like here, for example, with respect to this reference at the bottom, this is plus 18, this is plus 18. So only with respect to that bottom, this is plus 18 and this is plus 18.
Okay, means any type of change can be affordable, but that I current should be must same.
Yeah, correct.
Okay, thank you.
Okay, Gayatri.
Sir,
Tell me.
yesterday's problem, ladder circuit.
Okay, I'm coming there. Ladder, that was a conductance problem, huh?
No, sir.
Homogeneity. Tell me.
This, this 15 ampere and 15 volt. So can you please explain on one small?
See, from here, right side you start actually. Actually, I should find current, but I started by taking I as 1 ampere, right?
Okay, sir.
So when one is going through this 2 and 1, total 3 volts drop will come now.
Yes, sir.
The 3 volts also will appear across this 1 ohm because this and this system is parallel.
Yes.
So 3 volts will come here. Now 3 by 1, how much? 3 amperes now?
Yes, sir.
Now KCL. See, what is the KCL at this junction? This is 1 I took, this is 3. Total how much it will come? 4.
4.
Again 4 3s are 12 volts. Again KVL. 12 plus 3 volts. 12 plus 3 volts, 15 volts will come here.
12 plus
3. KVL.
Okay, sir.
12 plus 3, 15 volts. Again 15 by 1, 15 amperes.
Yeah, okay, sir.
Now again KCL. 4 plus 15, 19 amperes.
Okay, sir, I got it.
Again 19 4s are 76 plus 15, 91 volts. Like that KCL, KVL, you keep writing. Okay?
Okay, sir. Okay.
KCL in the loop, in the mesh, and KVL at the node. KCL like that you take. Okay?
Okay, sir. Thank you.
Okay. So tomorrow again 7 to 1, sir. Tomorrow will be very big day. We can close almost DC study state. Okay? Yes, tomorrow we'll meet again.